video, I want to look at scatterplots and how we interpret them. A scatterplot is a graph of ordered pairs of data values, and we use these to determine if a relationship exists between the two variables. In order to construct a scatterplot, our first step would be to draw and label our axes. The x-axis will contain the independent variable, and the y-axis will contain the dependent variable. We then graph each individual in the study as a single ordered pair. Let's consider this data set that relates the number of absences a student has with their final grade. In order to create our scatterplot, we're going to put absences on the x-axis and grade on the y-axis. This is because it's expected that the number of absences will impact our final grade. So the final grade will be dependent on the number of absences. We then plot each individual as an ordered pair. And we can see what this graph looks like here. Here I have another data set that shows the number of hours studied for an exam and the corresponding exam grade. In order to create a scatterplot for this, we'll put hours of study on the x-axis and the exam grade on the y-axis. This is because it's expected that the hours of study will impact the final grade and should thus be the independent variable. We then plot each individual as an ordered pair. We can see this scatterplot here. When looking at a scatterplot, there are two things we want to consider. The first is the direction, form, and strength. For this, we want to know if the graph looks approximately like a line, a parabola, or some other type of function. What direction is it moving as you read the graph from left to right? And how close of an approximation are the points? Do they follow the line very closely, or are they more spread out? The second thing to consider is any outliers. Are there any data values that don't seem to fit in with the rest of the data set? Let's take a closer look at the direction, form, and strength first. For the form, we're mainly going to consider linear graphs, so graphs that we can approximate with a line. That doesn't mean that these are the only possible graphs. It may be possible to approximate it with an other function, but we are going to consider lines alone. For directions, there are three things that could happen. It could be positive, negative, or none. A positive linear relationship occurs when the values for the x value increase, the values for the y value also increase. This is similar to the second scatterplot we looked at, but the idea is that the points move up and to the right. A negative linear relationship happens when the values for the x variable increase causes the values for the y value to decrease. This is actually seen in our first example where we looked at absences and grades, but the idea is that the points move down and to the right. Finally, no relationship may exist if there is no discernible pattern in the dots. They are kind of all over the place. The other thing we need to consider is strength. And strength refers to how closely the points resemble a line, but this can be difficult for the human eyes to detect. So we have a special thing that helps us with this. This is known as the correlation coefficient. This number determines the strength of our correlation. We use the letter R to denote this, and this value will always range between -1 and 1. Whether it's positive or negative relationship, whether that direction is positive or negative, will depend on the sign of the correlation coefficient. Strong positive linear relationships will have a coefficient that's close to 1. If there's no relationship or only a weak relationship, then this value will be close to 0. There's no hard and fast guidelines to the strength of a relationship, no formal cutoff points, but we can kind of estimate that anything within 0.7 to 1, either plus or minus, would indicate a strong relationship. Between 0.4 to 0.7, plus or minus, would indicate a moderate relationship. Anything between 0.1 and 0.4 Plus or minus would indicate a weak relationship, and anything between negative 0.1 and positive 0.1 would indicate no relationship. But like I said, this is not a hard cutoff, just kind of a general guide to how to interpret this. Let's look back at our example. This one looked at the number of absences versus the final grade. We can use technology to figure out that for this one, the R value is negative 0.978. This indicates a very strong negative relationship. If I look at my second example, the one that looked at exam grade versus the number of hours studied, in this case, we can figure out that the R value is actually 0.9616. This indicates a really strong positive relationship. Calculating this correlation coefficient can be difficult and tedious. Therefore, we're going to use technology to interpret this and calculate it for us. We just need to be able to understand it. There are an abundance of correlation calculators online that we can use in order to do this.
If you would like to see Professor Pierce make more videos like this one, you can support her on Patreon in the link below. Any and all support means a lot to her. It allows her not only to make more videos, but it also allows her to campaign for free and accessible online education to conferences and other universities. Thank you for watching, and remember, math is for everyone.